Okay, so we had been talking about heat right before we left for break. We're going to kind of just review heat, and then we're going to go into specific heat. So what we talked about heat was we talked about the difference between, excuse me, temperature, okay, and thermal energy. So temperature measures the random kinetic energy of one single molecule of a substance, whereas the thermal energy is the total amount of heat energy in a substance. So you're looking at the type of matter that you have and how much water and how much of that substance you have. The more of the substance you have, the more thermal heat that particular substance is going to have, because you have more of those molecules. So here, if you've ever boiled water, you know that the more water you're trying to boil, the longer it's going to take for that water to boil, because you have more of that water. So we talked about the 3 different ways that heat can transfer from one substance to another. Remember, heat flows always from hot to cold. So you have conduction, where it's the direct contact between 2 substances. Then you have convection, so you're talking about the flow of heat from hot to cold in liquids and in gases. And then you have radiation. Okay. Heat, or thermal energy, since you're still talking about energy, is going to be measured in joules. Okay, you can also measure heat in calories or BTUs. So here are just some conversions from the different units that you can measure thermal energy or heat in. Okay, we're going to be talking about specific heat. So you probably talked about specific heat in chemistry. We're going to really touch on it again. Okay, so specific heat is different for every substance. Okay, so let's pretend that you have a substance in a bowl and you don't know what the substance is. You can look at it, you can touch it if you want to, so you can look at some of the different properties. So you can see its initial temperature, you can see how much of the material you have. But let's say you want to raise the temperature of that material. How do you know how much heat you're going to have to add to that material or to that substance in order to get it to change its temperature? Well, you're going to want to know some specific information about that material before you can do that. One thing you're going to want to know is how much of the material you have, okay, what the material is, because you know that you have some materials that are good conductors of heat, where you have some that are good insulators. So you're going to want to know some things about the material before you're able to know how much heat you're going to have to add to it if you're trying to raise the temperature, or how much heat you're going to have to take away if you're trying to lower the temperature. Okay. This is where specific heat comes in. Okay, so specific heat is different for every material. Specific heat is how much energy is needed to raise the temperature of 1 kilogram of the substance by 1 degree Celsius. Remember, different substances require different amounts of heat energy, so some require less heat energy to heat up versus some other types of materials. Okay, for example, here you have 1 kilogram of water, and then you have 1 kilogram of steel. So the amount of the substance that you have is the same. And let's say you're trying to raise the temperature of each of those substances by the same degree. So let's say you're trying to take them from 19 degrees Celsius to 20 degrees Celsius. The change in temperature is the same, but you can see here that you need a whole lot more heat energy to raise the temperature of water than you do of steel. And that has to do with the specific heat. So here it should say the number, it's about 4,000, so more than 4,000 joules of heat energy, whereas steel only requires 470 joules of heat energy per kilogram. So water has a really high specific heat, which means that it takes a lot of time for water to change its temperature, which is why it does take some time for water to boil. So when you're boiling water, the pot that you're boiling it in is going to get hotter a lot faster than the water itself, because the metal of the pan or the pot is a good conductor of heat, whereas water is not. Okay, so every substance has its own specific heat. Here are some specific heats of different materials. Okay, so you can see the specific heat of water is 4,184 joules per kilogram degree Celsius. So that's how much heat energy is required to change the temperature by 1 degree Celsius of only 1 kilogram of water. That's a lot of heat energy. Oil is 1,900 joules per kilogram degree Celsius, and you can see the rest of them here. So you'll notice, that the conductors, are going to require less heat energy to change their temperature. So this right here is the formula to solve for heat energy. So if you're trying to change the temperature of a particular substance, you're going to want to know how much heat energy is required to do that, and this is the formula that you would use. So the formula is heat energy, which of course is measured in joules, is equal to how much of the substance you have, so the mass in kilograms, times the specific heat. So this is a particular number. This is a constant. Every material has its own specific heat. So this is just a number, a value that you would either know or you'd have to look up in a book. They have a whole book on all the different specific heats for substances, times the change in temperature of the substance. So here you would have the final temperature minus the initial temperature. So again, it would be the change in temperature of the substance that you're looking at. This would tell you how much heat energy is either lost if you're lowering the temperature or gained if you're increasing the temperature of the substance. So here are some practice problems. Number 1 says how much heat is needed to raise the temperature of a 250-liter hot tub from 20 degrees Celsius to 40 degrees Celsius. The specific heat of water is 4,184 joules per kilogram degree Celsius, and then they're telling you that 1 liter of water has a mass of 1 kilogram. Okay, so you can pause the video now and you can try plugging in the values to your formula and then see what you get, and I'll talk about it right now. Okay, let's go back. Okay, so here for this problem, let's look at some of the information that they're giving you. Okay, they're telling you how much, or the volume of water that you have in the hot tub. So you have 250 liters of water in the hot tub. You know the substance that you're dealing with is water. Okay, so 250 liters is the volume. Remember, liters measures volume. The specific heat, which is Cp, is equal to 4,184 joules per kilogram degree Celsius, right? So that, remember, that is specific to the substance that you're looking at. In this case, you're talking about water, so the specific heat of water is always going to be 4,184 joules per kilogram degree Celsius. And then the change in temperature, so delta T, or T2 minus T1, is 20 degrees to 40 degrees Celsius. So what's that change in temperature? How much is the temperature changing? Well, 40 degrees Celsius was the final temperature, 20 degrees Celsius was the initial, so 40 minus 20 would be a change in temperature of 20 degrees Celsius. So you have your mass, right? So you know the volume of water that you have is 250 liters. They're telling you that 1 liter has a mass of 1 kilogram. Therefore, the total mass of water would be 250 kilograms. It's a 1-to-1 ratio. So you have the mass, you have the specific heat, and then you have the change in temperature. So it would be 250 kilograms of the mass times the specific heat of water, which is 4,184 joules per kilogram degree Celsius, times the change in temperature, which we calculated it to be 20 degrees Celsius. Problem number 2 says how much energy is needed to raise the temperature of 2 kilograms of concrete from 10 degrees Celsius to 30 degrees Celsius, and then they give you the specific heat of concrete is 880 joules per kilogram degree Celsius. Again, you would pause the video now so that you could go ahead and try plugging in the variables into your formula and solving. So here, again, you're trying to figure out how much heat energy you would need to change the temperature of concrete. You need to know how much concrete you're dealing with. In this case, I'm dealing with 2 kilograms, so that would be the mass. The specific heat of concrete is 880 joules per kilogram degree Celsius. And then the change in temperature of concrete, again, I'm changing the temperature from 10 degrees Celsius to 30 degrees Celsius, so it would be a change in temperature of 20 degrees. So it would be 2 kilograms times a specific heat of 880 joules per kilogram degree Celsius times a change in temperature of 20 degrees Celsius. Problem 3, how much heat energy is needed to raise the temperature of 5 grams of gold from 20 degrees Celsius to 200 degrees Celsius? The specific heat of gold is 129 joules per kilogram degree Celsius. So for this particular problem, again, we're doing the same thing. We want to know how much heat I need to add to the gold in order to raise its temperature from 20 to 200 degrees Celsius, but my mass that I'm given is in grams. Remember, your mass needs to be in kilograms. So I'm going to have to convert 5 grams to kilograms, and then you can go ahead and plug in your numbers. Okay, so here's the mass. Again, I'm converting my mass from grams to kilograms. Okay, the specific heat of gold is only 129 joules per kilogram degree Celsius, and my change in temperature is from 20 to 200 degrees Celsius, so that would be a change in temperature of 180 degrees Celsius. Oops. Okay, so here are some more problems. I'm going to go ahead and let you work on these problems on your own, and then they're going to come up as questions on your Edpuzzle video, so you can check to see if you got them correct. Okay. Hopefully this helps, and if you need any more clarification, go ahead and send me an email. Hope you guys are staying safe and healthy inside your house. Have a great day.